right, so everybody should have out your textbook, your math journal, your toolkit, and last night's homework. You should have written down your homework in your plan book. If you have yet to do so, please make it happen right now. First thing we want to do is check with your group on homework answers. I forgot I drug the thing off of that screen. If you don't have your homework done, we know that we allow 2 business days to get that taken care of, but you want to try to get that done as quickly as you can. So take a couple minutes, check with each other on your homework questions, ask if you have any questions. If you had issues on something, see if your group also had issues on it. She just went to the office because her parents were in there. So, good strategy.
Would you get food?
And then take care of catching up on the previous one. So, you got 8. Today's homework. You gotta get on. Otherwise, if you're gonna dig your whole week. Neither of us did our homework last night? Okay, so that doesn't answer my question. Okay, so neither of us did our homework last night. Be honest. You have 2 business days, but see how pointless this is now? So figure out what you guys can do. Use this time purposefully. Maybe answer a couple homework questions. What's up? Yeah, I know. It's just hanging down. Like, this is too tight on button. It's not too tight. Yeah. Thank you.
Said factors help you like determine what the denominator. I understand that, but
Are there any big questions on the homework? I know you probably didn't have time to completely go over every question. We're just trying to do this quickly. Any big questions that we want to go over together? Any big issues? I know that we all do not have our homework done. Welcome to middle school. Welcome to really any grade level. Aside from good little elementary kids who do everything they're supposed to. It's also not true. They just look like it. So, here's the deal. When I give time to go over the homework with groups, if you haven't done anything on it, it's pointless for you. So figure out what to do with that time to make it somewhat purposeful. Writing down answers is pointless. When it comes to the test, you won't know what you're doing. So maybe discuss a couple problems with your peers. Look at somebody else's homework to help guide you when you do yours. You need the homework completed. I don't know if we get the big picture thing or not. You gotta do it eventually. So why not do it on time? Your group test, your team test, I'm planning on having Friday, which means I will be collecting your math journals then. Because Wednesday, you can already see Wednesday's assignment. Please don't let the assignment board confuse you. I have yesterday, today, and tomorrow's homework. So if you want to work ahead, you can go ahead and look at it. So I already have tomorrow's homework up there. That's the last homework for the chapter, aside from the closure, which we'll probably do the closure stuff together. So when I check your math journal, I'm going to be looking for those homeworks completed. That's going to be a mastery grade in math, and you don't want that to go on as progressing. That's just more to take care of later. Just take care of it now, so you don't have to take care of it later. So unless there's questions, which doesn't seem like there is because half of us didn't finish the assignment, we're going to move on. So at least a couple textbooks open at your group to section 1.2.7, please. In your either math toolkit, or if you've run out of space in your toolkit, you can do it in your journal. You want to date today's notes, 9/12. And our topic is 127, and really, it's compound probability. Compound probability. So check out this chore spinner. Anybody have like a chore wheel or chore chart or anything like that at home? Your chores change.
Oh yeah, I do.
I mean, I just have to do like all the chores. I don't have any child labor yet. So I'm gonna read our first paragraph here. Then we're gonna dive in as groups, just kind of looking at Thomas's chore wheel and trying to figure out some questions about that. So far in this section, we've worked with probabilities involving one specific desired outcome. I want to get the blue fish. I want to get the green fish. Whatever it was, we had one target. Now we're going to investigate probabilities of compound events. Compound events are events with combinations of outcomes. In today's lesson, we'll find the probability that either one of these events or the other event will occur. In chapter 5, we're going to go deeper into compound probability of both events occurring or neither events. Like, we go really deep into compound probability. Right now, we're just kind of dabbling with it. So here's the questions you want to think about. How is this probability related to the probability of a single event? Either what event or what other event are we interested in? And does it make sense? In probability, when would we know that an answer doesn't make sense? Like, what does probability have to be between? Yeah.
Say when you have a multiplication problem 17 times maybe 2, and then if you say 100, obviously it's not 100.
Okay, so think probability. So I like where you went, like you just made up a problem that didn't make sense. But in probability, when we think about our answers, they have to range between 0 and 1, or in percent value, that's 0% to 100%. And then as we go deeper, and now sometimes we can trust what things look like, sometimes we can't. Here we can pretty much trust what things look like. If I'm calculating the probability of rake leaves, and I get a probability that's bigger than a third, based on what that looks like, that wouldn't make sense. And if I start to try to add up the probability wheel, if I get more than 1, I know that won't make sense because the wheel together needs to add up to 1. So go ahead and dive into 119. As you get that done, move on to 120. I want you guys to kind of do checkpoints. As you finish a problem, stick up a hand and try to verify with me. And if I can't get right there, it's okay. You can move on, but I'll see that your hands up. Stick up a hand and verify with me that your answer is correct. So go ahead and dive into 119 and start trying to work through this lesson. I will cycle around and help you as need. Just got to put on a new band-aid. I read that. I'll do the whole class. You're diving into 119. Just dive in. You're good. Let me pause you for just a second to think about a question. If Thomas is told, go spin the spinner, what's the probability he will do a chore? 100%. Right? So now, here's the thing. Everybody answered in percent. Well, everyone that I heard. This is not in percents. So be careful if you're working in fractions or percent and you make that decision. You know a couple things are the same, a couple other things are the same, and you know it all adds up to 100 or 1. Work that to solve your unknowns. Sorry, keep going. I tried reaching in the fridge this morning.
I cut my finger on the left.
See, that sounds more like, say this is the fridge shelf, I was reaching in and just clipped the bottom of the shelf, like as I was going to get the coffee creamer, my hand was just too high. But whatever, little morning casualties. Yeah, don't do that. Don't do that. You don't know what's going on yet. I mean, write something down to start. I mean, just anything. We gotta get something on our paper. Yeah, make sure we're covering our cough. Try to vampire cough. We're in very close spaces, vampire cough. Like when the vampires bring their thing up. But you don't want to cough into your hand because we all touch the same stuff. So cough into your elbow. As we all get sick this winter, you don't want to spread it around. As you struggle, as we go through this class this year, I will slowly write some hints on the board. So if you don't have anything written down yet, you should be looking up and be like, oh, that's how I could start. We know that vacuum and clean bathroom have the same probability. So they are both a fourth because they tell us that in the problem. Vacuum and bathroom, same probability. So that I've notated right here. If you have nothing written down, write this down. Which leaves you with a probability of a half from the other side of the spinner. Now we can see that, but we've also now shown it mathematically. You cannot always trust what things just look like. I then try to take away from that half the bedroom to see what's left in those unknown wedges. But crap! Why did I say crap? And literally, you could write this in your notes to like, oh no! And we could make it all look, make it look very comic booky. Oh no, Batman! We can't subtract these fractions. Why can't I subtract these fractions?
Because they're not the same denominator. Yeah.
My pie slices are not the same size. I'm trying to take a third away from a half, and that doesn't make sense how I have it written because, well, if I went 1 minus 1 and then 2 minus 3, I'm going to get 1 over a negative 1. That subtraction doesn't work like that. So the first thing you have to do before you add or subtract fractions is make common denominators. So if you can't think of that, you should, in your notes, write off to the side that we need common denominators. To do that, the easiest, most effective, will always work no matter what. Multiply the denominators with each other. So I take my 2 times my 3, and likewise my 3 times my 2. But if I do it on the bottom, I got to do it on the top. Now what is this number divided by itself? This fraction, 3 over 3 or 2 over 2, what are we calling that? The giant 1. So if you want to remind yourself of that, notate this is one of our 1s, and this is one of our 1s, although my art skills are not lovely today. We're not changing anything. We're taking that chore wheel and cutting all the wedges to make them all the same size. So now what we've done is take the original left side and make it have 6 pieces. So now 3 of those pieces were the 3 of those pieces were the left side. We take 2 of them away and we're left with, if I had 3 pieces, I take 2 away, I'm left with how many pieces? 1, right? Because if I had 3, take 1 away, I get 1/6. But the problem is that 1/6, and I don't know if anybody threw like a quick drawing of this in their notes, but that 1/6 is this whole space. It's either of them. So I need you guys to figure out how you could solve, well, what's actually just the probability of rake leaves, or just the probability of do laundry. So back to you guys. Finish this up and then move on to 120. This really lets you understand what's going on just that much greater than the part. So when you pull this out, you're going to remember the chore wheel spinner, the fact that we were taking probabilities, subtracting from 1 to certain things equal. You're going to remember all of that from that tiny bit of notes.
Are we supposed to come over before we go to 120?
I think you put as much effort in trying to get notes down as you get to try and make the tackle. You're a whole lot more engaged. Just saying. You're picking and choosing where you put in the effort. Who can talk me through if 1/6 represented both of those wedges, rake leaves or do laundry, how I can figure out the probability of just do laundry? Is that a hand? Yes, no, maybe, yeah.
You divide it by 2.
Now, so a fraction divided by 2. I agree.
Multiply it by a half.
So when we need to split something, we're dividing by 2, right? So if we just said, well, the probability of either of those is 20%, it's not. 20% would be easy to work with. Split it in half, 10% each. But she said divide by 2. If I set up this, that's really weird. We will get later into how we convert this, but we also know dividing by 2 is the same as multiplying by half. Half of what you had. So here's a reminder, please write this down. With fraction multiplication, goes straight through the top, straight through the bottom, and we get a probability. I don't really want to write that in red, actually, because my next problem goes to red. That the probability he will do laundry is 1 out of 12. So he has a 1/12 chance, around 8%. So then the not probability. The not probability. If I said I'm going to flip a coin, I have a 50% chance of getting heads. What's my chance of not getting heads? 50%, right? So that's easy. What if I roll a die and I say I'm going to round here. Well, let's say I have a 20% chance of rolling a 2. I'm rounding, I'm stretching. But to make your life easy, I have a 20% chance of getting a 2. What's my chance of not getting a 2? So take what you're doing right there and apply it to this wheel. How am I going to figure out the probability of not cleaning the bathroom? Because remember, when I spin, what's my probability of doing a chore? 100%. I'm going to do a chore. Womp womp. So figure out the not bathroom probability. Then move on to 120. There's an easy way to do this and a hard way to do this.
Ooh, not the bathroom. Well,
So I hear good conversation on B. Go ahead, like once you're done with B, move on to 120. I'm going to bring you guys back together in like 7 or 8 minutes to go over some of these together. If you can't figure out how to do these, please stick up a hand so I can come help you. You're being very, very efficient with your notes. I might encourage you to put down just a bit more so when you look back at it, you can remember it a little bit better. Up to you, but just saying like a week from now, it's going to be hard to remember what that was in reference to. So, how do you know what the date is, what lesson
Good morning, Colin Tepper. Please come to the office. Colin Tepper to the office, please. Thank you.
Yeah. Like this or that. So we're gonna go over this and then we're gonna talk about that for a second. So in 119, if we look at not the bathroom, when I told you that my probability of getting a certain outcome was 20%, and you very quickly told me that the probability of not getting that was 80%, what'd you do? How'd you get 80% when I told you 20? Yeah.
I took 100 and
You subtract it, right? You take what you know, and then you take the everything and take away what you know, and you get what you have. Now, somebody I heard saying, well, to find out the not bathroom, we can just add up all the others. Well, we could. That is absolutely correct. But that's the long way to do it. The easy way to do it is say, there's a 100% chance I'm doing a chore. Take away my bathroom. Oh, crap, I'm not working in percents. So let's work with the numbers that we know. I'm working with the 0 to 1 scale. What's the chance of bathroom? 1/4. So then, to take that away, I need common denominators. So I multiply by my giant 1 over here. 4 over 4 turns that into 4 over 4. This is still 1. It in itself is a giant 1 minus the 1/4 now. And what do you get as your answer? Anybody? 3/4. And that's your probability of doing anything but the bathroom. Yeah.
I just made a stupid mistake. I thought clean bathroom and clean bedroom. I thought they were the same thing.
I know. Yeah, careful reading. So here's the thing. That's the probability of doing laundry or raking leaves or cleaning the bedroom or vacuuming. That's the probability of a lot of events. Just add it all together. So in 120, when it starts to talk to you about expressing the probability of multiple events together, we're actually going to switch screens probably here so that can stay up on the TV so people can get caught up if they want. So Thomas's aunt is fine if he's cleaning his bedroom or raking the leaves. So either of those wedges works. So she'd be happy if he lands in this wedge or this wedge. So we get the entire space between both of them. How do we express that as one probability? So essentially, if I took away this line and made it one big space, what would the chance of that big space be? Does that make sense? I will come around if that doesn't make total sense. But we're combining these two spaces to look at the either chance. She doesn't care which, but she wants him cleaning bedroom or raking leaves. And I'm going to grab a picture of the spinner too really quick. I will go back to that page, those of you that need to catch up on notes. I'm going to drop that right over here too.
So when we talk about the either situation, we're actually going to talk about the addition of the two probabilities. So if you're stuck, you can only go ahead and write down what's up there. Talk me through. You're stuck, check out the board. When we talk about the probability of either, we're actually discussing the sum of their individual probabilities. Did your answer ask you for a percent? Because probability actually goes from 0 to 1. Chance is percent, but if it doesn't ask for percent, especially since it's a repeating decimal, you really need to show the fraction and decimal if you're going to use that. So don't just leave the percent value, show the fraction also, because you want to show how you got there. You can't just have answers. Your notes have to have the work of how we got there. So you'd want to write out like the probability of cleaning the bedroom plus the probability of raking and show how it progresses down to get the answer. Same for you. You're writing down like the absolute minimum. These notes would not be a mastery because you barely have anything that we've done in class.
Guys, your notes cannot just have answers. Your notes should have what we've done to get the answers. So your notes can't just have like, oh, part B, here's a fraction. Like, it needs to work for how we got there. So in 120, A asks, what's probability to clean bedroom, what's probability to rake leaves? You could write in your notes, P of bed is 1/3, and I don't have a bunch of space up here. But in your notes, you can shorthand, but that doesn't mean don't write it. Shorthand means abbreviate, not don't do. And then you already figured out from earlier that probability of raking was a 12th. Then B says either. Now, it tells you in your math notes, I believe so, it's somewhere in either your book or your math notes, and I'm telling you now, when we talk about either, so let's say I'm flipping a coin again. What's the probability I get either a heads or a tails? Well, now that I don't care which, it's 100%. I will for sure get a heads or a tails. So I add them up. So to find this probability of either, I'm going to add my third probability with my 12th probability. Problem is, how can I do that? That's what you got to figure out. Talk with your teams, please. you've been writing down crappy notes, like the minimum, take this as an opportunity to reset with 120. It doesn't ask you to do a lot. A just wants you to put down both of the individual probabilities. B wants you to show how we're going to add up those probabilities. And you can't just do it. So your notes need to show how you would do it. Here's the other question. What if I collected one set of notes and that was your team grade for notes? What if I collected one set of notes? One person. I chose one person out of your group. Their notes determine your grades. What would you care about then? I wonder if you would care if Joe Schmo beside you doing nothing. I wonder if you'd care then. Oh yeah, I might do that, by the way. Not like tomorrow, but that's a strategy with CPM. Because if you don't care about your partner, you're not a very good teammate. So if they're writing down crap notes, like not doing anything, you should care about that. So we need to care about each other and make sure that we're all on the same page, quite literally and figuratively. So please write down the work that 120 needs. We're probably going to make this a 2-day lesson, and we're going to pick this up here tomorrow. Your only grade from chapter 1, by the way, is the team test. There's no individual test. So you have the next 2 minutes, because class is not over yet. I don't know why Goldring released this so early. You have the next 2 minutes to make sure that everybody in your group has decent notes for 120, at least where you are right now. Once you're confident that your group is all right with 120, at least where you stand right now, you're good to go. What's up? This B, we're going to go over that tomorrow. But, so you have the two probabilities separate right now, right? 1/3 and 1/12. To write them as a single probability, you have to be able to add them together. And to be able to add them together, what fraction is needed to be able to add them? Common denominator. So, how do you write the two outcomes as a single probability? You first make them as common denominators, sum them. That's how you write it as a single probability. Because then you'll know what it is. It's like, what would we multiply 1/3 by to get it into a denominator of parts? 4 over 4. So the top will become 4. The bottom becomes 12, but we don't really care about that because that does what we want. Now the top is 4. The other top is still 1. What do I get for that now? 4 and 1. What's 4 plus 1? 5. So it would be 5 over, what's your denominator? So that's 5 over 12. That's how you write it as a single probability.